you run up the stairs this morning? Did you ever wonder, after you run up the stairs and your heart pumps rapidly, how is that blood getting transported around your body? Or as you breathe, how is that oxygen get transported around? Or when you exhale, how is that carbon dioxide get transferred out? Are those just one of my blabberings? Perhaps, but the parts of our heart plays a crucial role in this. Greetings, I am Edlin C. ESPENILLA, the leader of Group 1 Pig's Heart Dissection. In this video, we will mention how the heart is dissected, the anatomical position of it in our body, and how its parts function in our system. Night and day, minute after minute, our heart pumps blood to all parts of our body to provide oxygen and nutrients it needs to function. The modest size of a heart is approximately the size of a person's fist. The hollow, cone-shaped heart weighs less than a pound. Now, let's determine the frontal plane of the heart. This is the anterior plane of the heart, while this is the posterior plane of the heart. So, let's take a closer look of the heart's external structure.
First, we have the apex. It is pointed and directed toward the left hip and rests on the diaphragm, approximately at the level of the fifth intercostal space. Its broad posterior-superior aspect or base, from which the great vessels of the body emerge, points toward the right shoulder and lies beneath the second rib, called the base.
Surrounding the heart is the pericardium. It is made up of 3 layers, an outer fibrous layer and an inner serous membrane pair. The loosely fitting superficial part of this sac is referred to as the fibrous pericardium. This fibrous layer helps to protect the heart and anchors it to surrounding structures, such as the diaphragm and sternum. Deep to the fibrous pericardium is the slippery, 2-layered serous pericardium. The parietal layer of the serous pericardium, or parietal pericardium, lines the interior of the fibrous pericardium.
Myocardium located below the pericardium is a myocardium consists of thick beadlets of cardiac muscle twisted and folded into ring-like arrangement. It is the layer that actually contracts.
At the front, we have the coronary artery. This blood vessel lies in the groove on the front of the heart, and it branches over the front and back side of the heart to supply fresh blood with oxygen and nutrients to the heart muscle itself. The left coronary artery sends blood to the left side of the heart muscle, while the right coronary artery sends blood to the right side of the heart. This includes the right ventricle, the right atrium, and the sinoatrial and atrioventricular nodes. At the back, we can see the coronary sinus. The coronary sinus is defined as a principal collector of deoxygenated blood from the heart, located at the posterior part of the heart, and it empties into the right atrium. It receives drainage from several veins, including the great cardiac vein and the posterior vein of the left ventricle.
Another artery is the pulmonary artery, where this blood vessel branches and carries blood to the lungs to receive oxygen and can be found curving out of the right ventricle. Let's take a deeper look at the essential blood vessels of the heart. These blood vessels are crucial for circulating blood and oxygen throughout the body and lungs, while also removing waste products.
Starting with the vena cava. It consists of superior vena cava and inferior vena cava, which are very large veins that bring the oxygenated blood to your heart to get oxygen. Your inferior vena cava, your body's largest vein, carries oxygen-depleted blood back to your heart from the lower part of your body, or below your diaphragm. Your superior vena cava, your second biggest vein, brings oxygen-poor blood from your upper body to your heart.
Next, we have the aorta. Is the main vessel through which oxygen-rich blood travels from the heart to the rest of the body. It also delivers nutrients and hormones. The aorta branches ensures these substances reach internal organs and nearby supporting tissue. On the pulmonary veins, it is a system of blood vessels that moves blood between your heart and your lungs. This circuit also includes your pulmonary arteries.
Next, let's locate the chambers of the heart. Left atrium receives blood full of oxygen from the lungs and then empties the blood into the left ventricle. Left ventricle, conical in shape with an anterior inferiorly projecting apex and is longer with thicker walls than the right ventricle. Right atrium, chamber of the heart that receives the oxygenated blood from the systemic circulation through the superior and inferior vena cava and the coronary sinus. Right ventricle is the chamber within the heart that is responsible for pumping oxygen-depleted blood to the lungs.
The septum is a thick muscular wall separating the right and left pumping ventricles from each other, and this prevents the mixing of oxygenated and deoxygenated blood. The tricuspid valve opens and closes to allow blood flow from the right atrium into the right ventricle during diastole. It's also called the right atrioventricular valve.
Aortic valve is between the left ventricle and aorta. Looking straight on, your aortic valve is near the middle of your heart. It opens to let blood flow from your left ventricle to your aorta, and it closes to prevent blood from flowing in the wrong direction.
Last but not the least is a pulmonary valve. The pulmonary valve is located inside the heart. It connects the right ventricle with the pulmonary artery. It's also situated to the right of the aortic valve. It manages the flow of oxygen for blood from your right ventricle into your main pulmonary artery. So, just a roundup of each part's function and how they relate with one another, here is one cardiac cycle. We're in to start. Deoxygenated blood flows through the superior and inferior vena cava, enters the right atrium. This atrium contracts, passes through the tricuspid valve. This valve closes and the right atrium relaxes. The blood is now in the right ventricle. This right ventricle then contracts, pushes through the pulmonary valve, which then closes. The right ventricle relaxes and deoxygenated blood in the pulmonary artery is on its way to the lungs to be oxygenated. So after the blood has become oxygenated through diffusion, it goes to the pulmonary veins, enters the left atrium. This atrium contracts, pushes through the bicuspid or mitral valve. This valve closes, the left atrium relaxes, blood is now in the left ventricle. This left ventricle then contracts, pushes through the aortic valve. This valve closes, the left ventricle relaxes, and oxygenated blood in the aorta is now ready to be distributed to our body tissues. As this video ends, I hope that we were able to showcase the internal and external structures of the heart, alongside its functions, and how each of these eventually lead to its successful cycle